Well, hello everyone. Paul here again. It's been a while, but got a new video for you. Hopefully you do fine where you're at. I'll tell you, I live by myself in my house. I know every wall way too well right now. But the good news here is we're going to do the Initio calculations experiment. This is the last of the labs for this semester. And then we'll see how things go. Now, basically, in this case, I have the GaussView here. This is Windows 10, but the computers, you'll have the start menu. If you click on the start menu, you'll see the first choice is Gaussian. Okay? Now, when you first open these guys up, I'll go ahead and I'll get on this click here, is that you're going to have a couple windows pop up. GaussView is what we're going to see initially. Okay? I always go ahead and move the windows so they're separated by a little bit. Now, what we have here, I'll show you, is that, here's all the menu items. And then here, this purple guy, that's actually where you build your molecules, okay? Now, if you put your cursor over them, you'll see that if I put my cursor over them, it'll show you what all these symbols mean. This is right down here. I'll say element fragment. If you look down here, you'll see it also tells you down there right away, ring fragment. Now, the ones we're concerned with, we're going to definitely need the element fragment. That brings up the periodic table that'll allow us to build our molecules. We're going to definitely make use of the modify bond. That will allow you to actually connect two molecules with bonds. We've also got a modify angle as well. And we've got an inquire. Inquire is good for getting information about bond lengths and bond angles. And finally here, we've got this what I call the red rock guitar. That's a delete atom. You end up putting too many things onto your purple area where you're building your molecule. You click on that and then you can delete one by one. Now, how do I go about using this? Well, first thing is, we'll start with the simplest, the hydrogen, H2. All right, now when I'm starting off, again, I'll clean my windows up a little bit. To build my H2 hydrogen atom, I'm going to click on this little element fragment right here. I'm going to move it down so it's not blocking anything. Now you'll see here, the default is carbon tetrahydral. Okay, this is going to show you what is going to end up showing up on here if I was to click. If I clicked over here, oh, there it is. But I don't want carbon tetrahedral. That's why we have the little red rock guitar that says delete atom. Click on that, and click, and it's gone. Now, I want to build H2. So I want to open up the table. I'm going to click on hydrogen. And then you'll see way down here, there's two choices. I got the H atom, and the default is the H2 already made. Don't go ahead and put all pre-made one on there. Let's build it. So we're going to click on the H atom. You'll see now that it's just a single hydrogen. I'll want to do it over here. This is where you build your molecule. I'll click once over here. Since I want two of them, I'll click another one over here. There we are. Every time I click, if I click too many, again, the rock guitar can get rid of it. Now I want to put a bond to connect it. That's modify bond right up here. And then I just simply say, okay, I'm going to click. I want this guy to connect to this guy. Click again. Now I got a choice, triple bond, double bond, covalent. We just want a single bond. And this tells you the distance for your picture that you drew. It's going to be a lot less distance than that. Okay, well, okay, there we are. Now before you submit it, it's good to click on the little clean button. It looks just like a broom right here. What it does there is based on basic bond lengths, it'll put it at more accurate distances. It'll speed up the calculation by a lot. There it is. Now, if I actually put my cursor in this purple box, where this molecule is, and I click the right key and hold the right click down, if I pull it towards me, downwards, you can see it gets bigger. If I let go, I can right click again, and I can center it. And with the left one, I can click on it and hold the left mouse button down. You can actually rotate it so you can see what's going on in any way you want. So that's convenient. Maybe not so exciting for H2, but more so for the other ones. All right, now I'm actually ready to go here. Now also notice I went ahead and made a folder on the desktop, put my name on it, Paul. That is where we're going to end up saving files from. We've also got this ab initio folder here. Inside of here, I've got two files. One is for the transition state, because you're not going to know how to draw the transition state. And the one of them is needed for the actual IRC, the reaction coordinate plot that we make at the very end. Okay, so those are all there. This is where I'm going to save my drawings. Now I'm ready to submit it to Gaussian. I'll just go to calculate up here. I want to do a Gaussian calculation. At this point, we want to tell what kind of job type. We're going to go ahead and do an optimization for a minimum energy. We want to know the actual lowest energy that molecule could have in its relaxed state. And this guy, we're going to leave it at negative. We're going to submit it. Now, it's not going to be able to submit yet because I haven't actually saved this as a readable input file. Do you want to save it as a Gaussian input file? Yes. Save. At this point, locate your folder. In this case, I've already got it set up, so it's going to go in the Paul folder. And then you're going to give it a name. I'm going to give it a name. I'm just going to call it React H2. I will point out, you will want to use small case letters here. The reason for it is when you actually submit it to Gaussian, and that's all the one that does the number crunching to give you the lowest energy, the results files are all capital letters. So you don't want to use capital, so you're not going to know which is which. So leave them small. We're ready to go. Oh, and before I actually submit it, I have to save it as a Gaussian input file. Otherwise, it's going to give me some errors. I'll save it. Okay, it's saved in this file. You saw it got populated right here in my Paul folder. Submit it to Gaussian, yes. Now if I go over here, this G button is Gaussian. You can actually see it doing some calculations on here. When it's finished, it'll prompt me to basically close this Gaussian window. It shouldn't take it more than about 15 seconds for it, because H2 it is. When it says job complete, you want to close the Gaussian window. That's referring to this. Oh, also, feel free to read the ridiculous little text that comes up at the end of each one, okay? All right, so we'll close it off, great. Would you like to open the results file? Absolutely. There we go. Now, in this case, I gotta find this results file. So I'm gonna need to tell it, files a type, it's gonna be all files. And notice here, this one's all capitals. That's how I know it was indeed the actual result, okay? And you can see here it's 1 minute later, so this is the one I drew. This is the actual lowest energy form, okay? So I'm gonna go ahead and click on that, and I'm gonna open it, because that's, and now I get what looks like a ball, but if I look at it again, I can actually click on it. Oops, don't even do that. And I can spin it around and see where it is. Don't worry if the bond's not there. It just has a habit of doing that, okay? Now I'm going to go ahead and cancel out of this. All right, again, I can make it bigger. I can rotate it. And now, how do I get the results? Again, don't draw the bond. If you do any modification, you won't have access. You go to the results, and you go to summary. When you go to summary, look at me various odds and ends. The most important ones here, really, the ones we really need to recalculate is this guy. That's the energy. That's the Hartke-Fogg method we're using. It's only negative 1.122. Get all the digits, record it into your lab manual or your report. Okay, that's what we need to get. This also, I want to find out any kind of bond lengths and bond angles. So once we've recorded this, now we're good. To get the bond length and stuff, well, all I have to do is inquire it. There's a question mark for inquire. And then I can just click once here, and it's going to tell me the distance in angstroms, in this case 0.73482 angstroms between this hydrogen 1 and hydrogen 2. There is no bond angle for this guy because it's only 2 atoms. Now for a bond angle, if there's a third atom up here, I would just go click, 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 and then it would give me the actual angles in degrees. And you need to do your SiH2 and SiH4 calculations for those bond angles, okay? So record the bond lengths, bond angles for the larger ones. And before I submit it, now, since I've already got the stuff on it, I can always just go back to my modify bond. And let's go ahead and put the guy back on. Okay? Great, now we're good. Now, I want to actually save this image. To do that, I just bring it up front. Under the edit, I can image capture. And once I image capture it, now it's in, it's saved, and I can just paste it into a Word document, and we're good to go. All right? So then you repeat this again for your SiH2. That's your other reactant. Remember that you have 2 reactants. You're going to get an energy for that one. If you add up the lowest energy for both SiH2 and H2, that'll give you the total of the reactant energy. That's going to be what we're going to end up plotting onto the IRC plot, which will give us information, valuable information on that. Speaking of, I think I have it right here. Yep. Here's a nice little diagram of what it often will get here. Okay, you'll have your H2, your SiH2. Notice it's bent because there are electrons over here, clouds. The transistor state might look like this. It may actually show a bond connecting here. It may look a little different. And then the SiH4. The thing about the SiH4 is very important. It needs to be tetrahedral, which means it's like having 3 bottoms and then one thing sticking up. If it's planar and it's flat completely, you will get the wrong numbers. So when you're building it, make sure that you don't have it as a nice flat frisbee. Make sure you make it 3-dimensional, okay? And up here, there is the IRC plot. And we get a lot of information. Now when you first get these numbers, you're going to have different numbers. You're going to have to basically, what we're going to do, what works best in my opinion, is whatever number that first value is, make it equal to 0. So it's minus 280. You want to add 280 to that number and the entire numbers. That way, instead of going from some negative to 0 or some to 0 at the end, we want to make the starting point 0. And the reason for that is then, once I have it 0, and then I multiply it by that 627, whatever that, convert it into actual more usable energy, then this right here is my activation energy, the difference. And if it's at 0, it's simply that number. And then my delta E will be the difference between initially and final. So in this case, it's a negative value. Those are things we need to report as well, okay? Have a discussion board, make use of the discussion board. It's there. If you have a question, maybe another student will come by and answer for you. Our TA will be on call looking through the discussion boards, and of course, hopefully we'll have too much trouble. It's kind of a fun program, and good luck on it. All for now. Be safe. Thanks.